That's in stoichiometry, right? Okay.
Oh, really?
So
We're not even doing anything exactly. Oh, let's not do that.
you're not doing what?
Learning in history.
In history?
Yeah. We watch March Madness.
We did that in here too.
Right, once you're done learning something. Yeah. Well, last time we did. What was it?
Okay. So let's say, for instance, now I'm just pulling this problem out of the book and a different author. So that is going to help you. So what we see happening here is ammonia is synthesized from hydrogen and nitrogen gases. Okay, so should we keep it simple and say that these are measured at STP, or you want to see the ideal gas law?
Ideal gas law.
Okay, so we'll just make this an ideal gas law application then. Okay, so it would say, for instance, that hydrogen plus nitrogen is needed to make ammonia gas, which is this. Okay, I wouldn't expect you to know what ammonia is, because I'm afraid if you are to go too fast, you put H4, and that's an ion rather than a compound. Okay, so we need a little more context than what we have here. If we have 5 liters of nitrogen, okay, so let's say we had 5 liters of that nitrogen. Okay, we have 5 liters of this. Okay, 5.0, what have you. Okay, and the pressure is at 3 atmospheres and the temperature is 298. So the pressure equals 3 atmospheres. I guess I could put volume equals this, and temperature equals 2. What did I say? 98 Kelvin. Okay, so what we're wondering is how many grams of ammonia gas will be produced. Okay, so let's look at it. Let's say we had hydrogen. We have 5 liters of hydrogen. Okay, that'll make more 5.0 liters of this. Oops. So then, how many grams of ammonia would be produced? Okay. Now, we can actually do this both ways. Now, the reason I say that is, how many of you are in ideal gas law? I mean, you have to use the ideal gas law. There's no way of getting around it. But you're still going to have to use dimensional analysis of some sort. Okay? So how many of you are more so if it's at STP? I'm just going to go and use dimensional analysis all the way through. Okay? So my question is, how many ideal gas law people do we have? Okay, so then is it 1, 1.5, 1.5? So then 3.5 are, sorry, we got 6 people in there. See, we have 5. So, so we have 4.5 are dimensional analysis then? Yes? 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 Yes. You haven't decided, but you're ideal gas law. Okay, so one of the aspects that we see here when we're dealing with gas stoichiometry, remember from earlier this semester, reaction stoichiometry has meant what? What do we have to have? In any stoichiometry problem, reaction, we have to have chemical reaction. Okay? And what do you have to do with that chemical reaction? Okay, so hydrogen is what? Nitrogen is what? Okay, and that gives us our NH3. All right, so the next thing we need to do is what? Okay, so we've got 3 hydrogens here and 2 here. So these come in pairs, these are odd. Get this up to an even number by doing what? Okay, so are the nitrogens balanced? Yes. How many hydrogens are on the right?
6.
So what do we need here?
3.
Okay, so now what we have to do is notice we have to find the number of moles first. Because here we have to use the ideal gas law, okay? Which means, of course, pressure times volume equals NR and T. So we've got pressure of 3, okay? So that's what I said earlier. 3 times what?
5.
Times 5, because of the volume that we have here, equals, okay? Now, what is going on the right-hand side? Do we have a number of moles? No. But we did have a place to start, this 5 liters. Can we just take 5 liters and convert that to moles? No. If it was measured at STP, we could. But it's not. So we have to compensate for all those with this pressure, that temperature, at that volume. So on the right-hand side, what do we have? We have 3 variables. See, what are we going? You already know how to do this stuff, which is great, right? Oh, okay, fair enough. And then that's times 298. And then, of course, is times n. All right. Kind of concerned that we might have a little bit of a glare here, so I'm going to shut the blinds a little bit. When you do go back and watch these, if you choose to, is it any problems reading or seeing the board?
There is sometimes just like a glare on myself.
So, because if I'm standing out here now and I'm looking, that's probably way too dark to be recorded. Okay, has there ever been any issues? That's my question. No. All right.
Unless the marker's too light, when these are on my hands.
Okay, and I think these are probably okay. All right. So the next thing we want to do is get n by itself. Okay. So to do that, what are we going to do? Okay. So let's flip-flop these. Take 0.0821. 24.6. 0.65.
Wait, 24.4658.
Yeah, so I said 24.47.
Well,
All right, so we've heard. Okay. 24.47. Okay. What was over on the right is now going to be on the left. Okay. What else is left over? So we have n equals 15. So now n equals 0.61. Okay. Now that is what? N is number of moles of what though? Okay. Now, one of the things I would suggest, even when you get to this point, the next thing you should do is anyone see anything that's missing in that step? Okay. Granted, that would not be utilized again, but it's just good practice because the reason I say that's not utilized anymore is because we're not looking for a mass of hydrogen. But sometimes that can't happen. Some of the papers that those quiz grades were entered into the grade book, so you can take a look at them, but I need them back, they have been recorded. And some people are off by a factor of 2. The most common reason would be what? Yeah, they don't take into account that these elements are diatomic. Now that we have this, now again, this is the ideal gas law application. Now that we have this in moles of this substance, now you have to use dimensional analysis. And how would we go about doing that? So we've got 0.61 moles of that. So you can either start a new line or just continue out with this. Okay, so that's what we'll do here. So how do we get this mole of hydrogen? Remember, we're on the left-hand side of the reaction. We need to get to the right-hand side. So what's our next? A mole to mole ratio. What goes on the bottom? So mole of H2 with what goes on top. Okay. Now we'll say we're going to go back to our balanced chemical reaction. We've got 2 and 3. The 3 goes on the bottom because of this. The 2 goes on top because of that coefficient. So now we're in moles of ammonia, but we need what? Okay. So how do we get rid of this mole? Okay. Oh, we have moles here. We should probably put a 2 down here. No, we don't. Why not? Because it's not a mole to mole ratio. Okay. Six grams of NH3. Okay. Yes, it is.
How many questions are on tomorrow? Is it just like these problems and then STD problems? So like any like funky thing we have to like do we need to know the density?
Maybe. I mean, that's simple.
But it'll be out there.
No problem, like volume, like liters and milliliters.
This does have volume in it.
Can we do
Well, I know that, but like one that's more focused on it.
So can we erase this?
Yep, yeah.
All right. So for instance, we could say that the reason that we're going from a volume to a mass or a mass to a volume, those are a little more difficult than just dealing with volume. Okay? Because to me, if you can understand the mass to a volume or a volume to a mass, well then volume to volume is going to be pretty simple. Not simple. I mean, there's places we can make a mistake, that is true, but go ahead and keep going then. So let's say, for instance, at STP, okay, we're going to say maybe something like this. So at STP, oh, how many grams of, oh, I don't know, let's say lithium, I don't know, I just saw some batteries and lithium ion batteries, so lithium are needed to release, in other words, let go, liberate, whatever. Come up with a number for you. .15 liters of hydrogen when lithium reacts with water. With water. Okay. So I'll give you a couple moments to write that down should you choose. Yes. So here again, we can just point the computer down and still have the sound on. And one of you can come up here and explain this because it's got to be boring listening to the same person. We try not to be so monotone. Hopefully it doesn't come across that way. But, oh, we've got a taker. Okay. Okay.
What would, like, would it be just LiH2O then?
Those are your two reactants.
Right, but then for the ending on the other side of the
Okay.
arrow.
So we can proceed forward. So we know we've got. So what do we know is going to be on the right hand side? Because you correctly said the left hand side. We've got Li, and what's that reacting with?
H2O.
Okay. So what do we know is on the right hand side? Because what are we looking for? Right.
No, okay,
Lithium oxide.
I don't know.
Okay. Yeah, it's a single replacement. So what we could do here then is this lithium will react with that water. It'll kick the hydrogen out of there. So that will give us LiOH, and then plus what's left over?
O2.
No.
I don't know.
What was it? H2 or O2? Are we sure?
It's H2, I guess.
Okay. We're asking for it right there.
There, that's
Okay. So now, since we have something measured at STP, how many of you would just use straight dimensional analysis and that's all you gotta do? Nobody.
I really don't have to do it. That's all the problem.
Nobody.
Oh, I would
One.
use
Just one. Two.
Cool. Depends on the problem.
this problem. Okay.
I don't know about this one.
That's
I'm
TV.
thinking it. I know.
Okay.
I'm
So
still thinking.
let's go ahead and we can do them simultaneously. Okay.
No.
There's a nice fancy word for you, simultaneously, because we've got a pressure of what? 1 atmosphere. We've got a volume of what? Okay. And then we have R. And we've got T. Okay. But we just don't have N. We just don't have the number of moles. So what we've got here is this reaction, but we still need to do what with it? Okay. So let's go ahead and take a peek at that and say, well, okay, we've got 2 hydrogens there and 3 of them over here. Well, so let's try to get these 3 up to an even number. And the best way to do that, okay, if we put a 2 here, okay, this is where that simple math may let you down. I'm not saying it will. Okay, so how many hydrogens are on the right hand side now? 4. And how many are on the left? So if we put a 2 here, our hydrogens are balanced, but now are our oxygens balanced? Yes or no? Yes, they are. Now we've got 2 lithiums on the right, so what would we put here? All right. So with this, okay, we are trying to figure out if we want to release 0.15 liters of this. 0.15 liters is asking for what? How many grams of lithium? Okay. So if we are an ideal gas law person, that's fine, okay? Because remember, on that right-hand side, you can, it's almost like you can bypass a step because we already established 273 times 0.0821 equals what? Right? Yes. And we can make some presumptions here because we already know that since it's measured at STP, this would be utilized somewhere even in the dimensional analysis. Okay? So if we have P, V equals N, R, and T, well, we've already established these 2 times one another are 22.4. We just have our N. So what's on our left-hand side now? 0.15. Well, we don't have to take it times 1 because we already know that would give us 0.15 anyway. So N equals 0.0067. Now, that's moles of what though? Okay, moles of hydrogen. Now, we're not looking for a mass of hydrogen, but again, I can't stress that enough. It's just a good idea to keep consistent writing it as H2, O2, what have you. All right, so now is when we're going to use the dimensional analysis. Even if we are an ideal gas law person, because what would we do with this to try to convert liters of this to a mass of lithium? I didn't put grams up there, did I? Okay. Okay. So to cancel out this mole, what do we put? Mole of H2. Two there and 1 there. So this 2 tells us we need to put that there. Okay, on the bottom. So now we're in moles of lithium. How do we get rid of that? Mole of lithium, and what goes on top? Okay. 0.093 grams of lithium. Now, let's say, for instance, you're just a straight dimensional analysis person. And that's fine. What you can do is do this all in one step, because with STP, we can take some certain presumptions and say 0.15. Don't try to intermix these two, okay? Don't try to mix the ideal gas law with dimensional analysis until you've solved for moles, okay? So again, you have to decide which type you're going to do. All right, so how do we cancel out? Okay. Liters of hydrogen and a mole of hydrogen. And notice, we know we got to divide because even that's what we did up here. 0.15 was divided by 22.14. Okay, So now we're in moles of hydrogen. What is our next step? So mole of hydrogen gives us moles of what? Okay. And then finally, we get rid of our mole of lithium and put one on top. Okay. So some people just like to remain consistent and say, I'm always going to use the ideal gas law because I know it works and I don't have to worry about mixing pieces and parts.
Wait, so what was the difference
With what part?
with volume?
Okay. So if you're utilizing the ideal gas law portion, you have to find the number of moles first. Okay? That's if you're an ideal gas law person. Okay? But if you're a dimensional analysis person, you can go ahead and jump right into the problem and convert the number of liters by taking the presumption of for every 22.4 liters, you get a mole of that gas. Okay? So, and I would highly suggest if you were an ideal gas law portion or person and we went over this, that you just don't pay attention. But if you are a dimensional analysis person, well then don't listen when we're doing the ideal gas law. Because again, if you try to mix the two, you're going to have problems. In other words, if you start with grams or have grams other than here at the end, you could possibly have problems.
So if we were to do dimensional analysis, we use the volume?
Mm-hmm. Yes. That's the only way you can make that conversion from a volume into a mass eventually, or into a mole. So, with a little luck, that will give us the same answer. We're very comparable to 0.93.
Yeah.
In other words, it does?
Yeah.
What a coinky dink, right? So, we any more comfortable with this than before we started?
Yeah.
Okay. So left outside. Are we ready? Left middle. Right middle. Right outside. Getting there. All right.
So on the exam that we took, I didn't use 22.4.
Okay. Hold that thought. Okay, we'll pick up with this at a later time.